Selamat sejahtera to lecturer for this Electrical Engineering Pspice Lab, Dr. Noor Hafiz bin Salim. My name is Tan Hong Yi from 2 BEKG as well. Today I'm going to present and explain about part A for Pspice Lab, which is RLC transient. First of all, this is a RC transient circuit. A RC transient circuit contains of capacitor, resistor, and AC voltage source. So this will be the graph for voltage across the capacitor. So as we all know from the theory, the function of capacitor is to store charge. So there will be a charging part and discharging part for the circuit. Each point we are looking for is actually voltage across the capacitor. Each point we are looking for is actually the time for each delay by the voltage source, which is called tau. Tau, we are multiplying both R and C. So this will be all the value at each tau for charging and discharging part. The next circuit is RL transient circuit. So this will be the equivalent circuit, which we have R and L and AC voltage source. So this circuit is same as the RC circuit. We just changing the capacitor to inductor. So for the graph, we will have charging and also discharging part for current across the inductor. So we are also finding the inductor value for each tau. Next, this will be an RLC circuit which we have resistor, inductor and capacitor, and also voltage source. So this circuit is a second order circuit which we need to find the value of alpha and omega naught to determine the type of graph. So, by observing the graph, you can know that this is an underdamped cases. After calculating the alpha and omega naught, we can observe that alpha is smaller than omega naught, and this is an underdamped cases circuit. Next, this is also an RLC series circuit. This circuit is same as the previous circuit. So when t is greater than 0, this circuit will become a step response RLC series circuit, which we have voltage source, R resistor, inductor and capacitor. So after calculate the value of alpha and omega naught, we can conclude that the circuit is underdamped circuit for 1 ohm and 2 ohm, while the circuit will be overdamped if the resistor value is 5 ohm. So that's all from me. Thank you so much.
My name is Lu Jun, and today I will do the Part B RLC resonance simulation. So this is the RLC circuit from the left sheet, and I need to simulate it on Pspice. So this is the circuit which is already placed on the Pspice, and there is Vsin, capacitor, inductor and resistor. So the value for the Vsin is for AC is equal to 1 volt, voltage amplitude is 1 volt, and the frequency is 100 kHz. So after I check all of the circuits, so I can do the simulation. And the simulation is like this. So I will get this graph from the Pspice and I copy it to the Microsoft Word. So this is the simulation result of RLC circuits, which is on Pspice. So I can get the resonance frequency from the top of the graph, which is 5.7 kHz. So in order to find the two half power frequency, I need to do some calculation. So this is the calculation. So we focus on the experimental result first. So this is the resonance frequency I get from the graph. So I will use it to calculate the quality factor, bandwidth, and after that I will calculate the two half power frequency, which is 5.23 kHz and 6.22 kHz. So I use these two half power frequency and plot on the graph. So I will get this value. So after that, we need to compare with the theoretical result. So we need to do calculation again. Here is the theoretical result, which is the procedure is same as the experimental result. So first we need to calculate the resonant frequency, which is 5.65655 kHz, and we calculate the quality factor, the bandwidth, and the two half power frequency. After we get all the value, we do it on the comparison table, which we can compare the theoretical result and the experimental result. So we have resonant frequency, half power frequency f1, half power frequency f2, and quality factor and bandwidth. So this is my presentation for Part B. Thank you.
Okay, good morning, doctor. Hi, I'm Paul. So today I'll talk about the parallel circuit in the Part C. So we have three types. First is RL or RC. The second one is LC circuit. And the third one is RLC. So a special mention here is that for inductor branch, alright, all inductor branch we got at a 240 ohm resistor, so the summation can work perfectly or fine, because without this resistor it will be not working fine. So let's move on to the result. The case 1 with resistor and capacitor. So how to look at this graph? For the IV1 is a green line, is overall current. So for the origin, we use the current resistor current as origin, and we can see that the blue line capacitor current is left side, which means it's leading, thus causing the overall current to the left side, which is leading. So move on to the R and L. You can see that the inductor current, the blue line is the right side, and the green one overall current is also right side, which means it's lagging. Okay, for L and C is almost the same thing. And you can see that the red line is the capacitor current, is the left side, and the inductor current is the right side. Then the overall current will be in the center of this both. And for case 4, also the same. Alright, so from here we can verify that the theory is correct. According to the Civil rule, it means the capacitor current will always leading the voltage, while the inductor is vice versa. The current is lagging the voltage. So you can see that the current capacitor, the red line, is always the left side, which is leading the capacitor, and compared to the inductor, the right side, which is always lagging. So more to 5 and 6 and 7, which is the RLC, which is meaning resistor branch, inductor branch, and capacitor branch. So here the yellow line is capacitor, the red line is inductor current, when the blue line is overall. So as always, the resistor current acts as the origin. You can see that the overall is left side, which means the overall current for this circuit is leading. And for K6 is also the same. The blue line is the left side, and compared to the green line. So this circuit current also leading. So on this case 7, also the same, with the current, the overall current also leading. Okay, compared to green line, the origin is the current. So we also got repeat K6 with 100 Hz. You can see that the waveform or the cycle is more compared to origin K6. Alright, due to the higher with higher frequency, the lesser the time frame. So to complete a full cycle. So when using the same amount of time, the ms, so we got more cycle in this. So repeat the K6 with lower voltage supply, which 120 compared to original 240. So more the result for this experiment, we got we go find the measurement, and also we do calculation to find the expected result. So overall, the expected result is similar to the measurement, is not far away, so it's considered the theory is verified and it is usable. And for the lower voltage with the K700 is lesser for all parameters for IS, resistor, inductor, and capacitor. So that's all for me. Thank you.